Okay, so we're on to our actual demonstration. As you can see, I've got my safety glasses on. I just wanted to go through the procedure for this reaction before I went ahead and did it. So we're doing a titration of this acid, of an unknown acid. Remember, the sample we're imagining was taken from a stream that was polluted with acid. So at the end of the day, we're going to use this equation, which tells us that the moles of acid, or the molarity times the volume, has to be equal to the moles of base, or the molarity times the volume, to reach the equivalence point. And we're going to use an indicator to help us find out when that is. So we'll do the calculations after the experiment, but for now, I want to go through the procedure. So we're going to start with a 40 milliliter sample of acid, which I have right here. So I've put it into a little flask. You can see maybe that it's around the 40 milliliter mark, coming into focus barely there. So say you took that from a stream. Obviously, I made the sample up myself using chemicals, but you could go take a sample of some actual acidic water if you wanted to. We're going to add an indicator to it that'll turn pink. That's going to be phenolphthalein when it becomes slightly basic. So when I first add it, nothing's going to happen, but when it becomes basic, it'll turn pink. Then we're going to slowly add some sodium hydroxide. You might notice that sodium hydroxide is a base because it's got a hydroxide at the end. Of a known molarity or a known concentration. So we're going to be using sodium hydroxide that's a concentration of 1.5, and I have it in this beaker here. We're going to keep adding it slowly until the indicator turns slightly pink. There's a bit of a nuance to this, so I'll kind of show you when we get to it. And then at that point, that's the volume of base that neutralizes that volume of acid at that concentration. And then we'll do the calculations. So I'm going to go ahead and switch over to my camera, and I'm going to walk you through the steps for setting this up and doing a titration safely. Okay, so what I have here is called a Buret. You'll notice it's kind of like a cylinder, a glass cylinder, but at the top it has a 0 and it counts down from there. If I zoom out a bit, manual zoom, you'll see that this long container, this long cylinder, actually at the bottom has a little valve. If I open and close this valve, like so, by twisting this knob, then water will drip out, or whatever's contained inside the Buret will drip out at the bottom. So I'm going to close that for now. What I'm going to do is fill up this Buret. I'm going to move this is our acid solution. What I'm going to do is fill up this Buret with the basic solution that I prepared earlier that has a molarity of 1.5. So I'm going to go ahead and pour that in up at the top until it reaches the volume of 0. All right, as you can see, I've filled it up to the 0 mark with the base. So the whole Buret is ready to go. I've got my acid here, and I'm about to move on to the next step. Okay, so here I have my phenolphthalein indicator. So if you watch the notes, you know that I need to add a couple of drops of this to my acid so that I'll know when this thing turns into a base. Something else I wanted to do was maybe show that this was an acid by using a pH strip. But I'll start just by getting some phenolphthalein. Just going to add 1, 2, 3 drops in there, maybe 4. And that is all I need. You'll notice that immediately there's no color change, and that's because phenolphthalein only turns pink in the presence of a base. However, in our case, this is still an acid, so no color change. This just looks totally clear. So I have it here underneath my Buret. Now my Buret is sitting at 0. You guys can't see, but at the top of the Buret it measures 0. So I'm going to be dripping out slowly some volume of base until it neutralizes the acid inside the acid container, and then turns the phenolphthalein the color pink. So we're going to go ahead and do that. So as I open this valve, some of the base is going to start dripping out. And so I'm going to let it drip kind of at a slow rate, if I can get it. So just a few drips at a time while I kind of stir this around is sort of the best way to do it. And hopefully you can still see, oh, my hand is blocking it a little bit. Hopefully you can see the solution swirling around a bit, but I'm basically watching the solution to see when it starts to turn very slightly pink, and I'm going to slow down. So I'm looking. Some of these drops are kind of turning pinkish a little bit. Okay. I'm not seeing any long duration pinkness. So the drops will sort of turn pink and then go back to clear. So let's stop it there. And even though I've added all the way from 0 up down to 10 on my graduated cylinder, there actually has been no change in the color here. And that's because even though I've added some base, I haven't added enough base to equalize the amount of acid that's in here. However, I'm going to need to start adding a little bit slower because I don't know when I'm going to get to the point that I've added enough base. So I'm going to drop the base, bam, like dubstep, but very slowly here. And so now it's just coming a drop at a time. And you can see even those little drops start to turn it a little bit pink, but then as I stir it up, it goes away. So we're getting very close to what we would call the equivalence point. So I'm going to drop it even slower. Now you can see that it's turning flashes of pink with every drop. Every drop is causing it to turn pink for a few seconds. But then if I stop it, which I just did, it's pink right now. But then if I stir it up, it still goes clear. So now we're getting really close. Oh, so I gotta be extra, extra careful. And I want to make it so that it will stay pink for a few seconds. So it was 1 drop, 2 drops. And you might have seen that. It got really dark pink, but then it turned away once I got it close. So far we've added 14.9 milliliters. So I'm going to add just 1 more drop if possible. As you can see, there's a bit of a slow process in real life. And that's 1 drop. Bam, that's all I want to get in there. And I'm going to stir it up. You can see it turns a dark pink color just with 1 drop. And as I stir it, it gets a little bit lighter. And so I've got a nice light pink color there. And it's possible that this will clear up in another few seconds, and I would add another drop, or I could take the volume measurement that I have now. It's a bit of an art to it. Partly because phenolphthalein doesn't turn pink at exactly 7. It turns pink actually a bit after 7. So you want to kind of stop it before you get to exactly that point. But I think that that's going to stay pink for at least an appreciable. Oops, a little high. I think that's going to stay pink for at least an appreciable amount of time. You can see maybe against the white container there's a light pink color. So I'm going to go ahead and put in my volume that I measure on the Buret, which maybe I'll help you guys see with another camera, but it looks like almost exactly 15 milliliters of water. So yeah, give me 1 second here. As you guys can see, that liquid is right at that 15 milliliter mark. It's hard to see because of the focus on this camera, but it is the bottom of the meniscus is right at the 15 milliliter mark. So that's the number I'm going to write down. And now we're going to go ahead and do the calculation. So as you can see, I'm going to use this equation. The molarity times the volume of the acid equals the molarity times the volume of the base. So when those two are equal, you'll get to the equivalence point, which is what showed us this little this pink solution of phenolphthalein. So we know, I'm going to plug in the things that we knew ahead of time. So we knew the volume of the acid we were using. We measured that. It was 40 milliliters. That was how much of a sample we had. And we knew the molarity of the base. That was 1.5. So I'm going to paste in this line that I have here. So 40 milliliters of acid and a 1.5. So then we did the experiment. I did the titration in front of you guys. I didn't know exactly what the answer was going to be. And we came up with a volume of 15.0 milliliters. I didn't plan for it to be exactly that amount. It could have been 15.6 or 15.2, but this is what I got off of the Buret, so 15.0 milliliters. And so that was what we had. And now what we need to solve for is the molarity of the acid. So the way I'm going to do that is I'm going to divide both sides by 40 here. So I'm going to have, let me just copy and paste one more time. Control V. So I'm going to divide both sides by 40. That's going to take this and bring it over here. So divided by, not times 40, but divided by 40 milliliters. So I have 1.5 m times 15 milliliters divided by 40 milliliters. That's going to cause these milliliters to cancel out. And then I need to do the algebra with all these things. So I'm going to open up just the calculator. So 1.5 times 15 divided by 40. 1.5 times 15 divided by 40 hit the enter key, and it gives me 0.5625. 0.5625. And so that equals, maybe I'll do it in red, 0.5625 molarity. Now, how many decimal places should I keep here? Scientifically, I should really only keep as many decimal places as I had in my original measurement. So I didn't have exactly 40 milliliters, it was probably like 40 and a half or something. And then also this 1.5 is kind of given from a bottle that I pulled out of a shelf, which might have been, 1.51 or whatever. So it doesn't really make sense to keep all of these digits of precision. Might as well go ahead and knock off these last couple digits and leave it as 0.56 molar. So basically what this is saying is that this solution, this acid sample, before I added the base, this must have been the concentration of the acid when it started. And because I took that sample from the stream, I mean, of course, this is a made-up lab example, but since I took that concentration from the stream, I can assume that the rest of the water in the stream is going to have that same molarity. And with that information, then I can go ahead and do some more math, some more advanced chemical engineering to come up with a solution that involves neutralizing that acid. But it's going to look, the math is going to look a lot like what we just did here. And so that's basically all I have for this video. So best of luck.